Hello students, hi, welcome back. So I hope you are doing good. In this part we will be discussing about your nomenclature concepts of your phenols and ethers. So let's start this part. Naming of phenols. So how to name a given phenol, or what is the nomenclature of phenols? So just like hydroxy, the hydroxy compounds, the simplest hydroxy derivative of benzene is phenol, and this name is used as a common name as well as an IUPAC name. So phenol is not only a common name but also an IUPAC name for a benzene containing an alcoholic group. So now in phenols also you have different other phenols which can be possible, right? One is orthophenol, right? For example, you have phenol and you have ortho position. This is ortho position, this is meta position, and this is para position. So at ortho position you may have some substituent, at meta position you may have some substituent, and at para position also you may have some substituent. So if it is a 1,2 disubstituted, it's an orthophenol. 1,3 disubstituted, it is a metaphenol, and it is if it is a 1,4 disubstituted, it is a paraphenol. So these are the other common names for the given phenols. So for example, you can see here bromine is present at the second position. So it is a 1,2 disubstituted phenol. So it will be what? IUPAC name will be 2-bromophenol. And what is the common name? Common name already told you, it is a ortho-bromophenol, since bromine is present at the ortho position. Here your NO2 is present at the third position, which, right, first position is the alcoholic position itself, second position is this, and third position is this. So Na2 is present at the third position. So it is 3-nitrophenol, which is the IUPAC name, and common name is nothing but a meta-nitrophenol, because it is 1,3 disubstituted, and 1,3 disubstituted is a metaphenol. And if we have at the fourth position, so you know that fourth position, for example, it is 1, 2, 3 and 4. So fourth position substituted molecule will be at a para position. So here it will be 4-ethyl phenol, or else it can be a para-ethyl phenol. So nomenclature of phenols can be simple, alright, because IUPAC name is simple, and because you are mentioning the position of your substituent, and common name is ortho, meta or para depending on the position. Now what about the nomenclature of ethers, right? Ethers also have to be given some names, right? And let's see how ethers can be considered regarding the nomenclature. So if you consider the common name, what you have to do is you have to write separate words for alkyl and aryl groups in alphabetical order, and then add the word ether at the end. For example, you have CS3, CS2O, CS3. Now what you will write this as that, here on the one side you have ethane, I can say ethane group except one hydrogen, and other side you have methane group. So now I can consider this as a ethyl group, I can consider this as a methyl group. Here also I can consider this as a phenyl group, right? Remember I told you that if your C6H5, which is benzyl, right, if it is a substituent, it is a phenyl. So this is a phenyl, and the other side is the ethyl. So it will be ethyl methyl ether, because you have to write the separate words of alkyl groups in alphabetical order, and if I write in alphabetical order, obviously ethyl group first and then comes methyl, because it is E, this is M. So it will be ethyl methyl ether. It will be what? It will be ethyl phenyl ether. So the alphabetical order plays an important role. And if both alkyl groups are same, add prefix di before alkyl groups. For example, instead of methyl group, here also you have CS2CH3, that means it is again an ethyl group. So you will write as diethyl ether, because you have two ethyl groups, that means it is you will get a prefix of di, so it will be diethyl ether. So now here you have a phenyl group and you have isopentyl group. The logic is again same. right? You have to use the alphabetical order. So if you use the alphabetical order, here you have phenyl and pentyl. Here this is isopentyl, but you have phenyl and you have pentyl group, because CH2 CH2 CH CH3 twice is a pentyl. You have 5 carbons, but if I closely observe that, it is an isopentyl. So whenever you have isopentyl group, remember it will be followed by the phenyl group. So phenyl, isopentyl and ether. So you have to select the longest carbon chain as a parent chain. It decides suffix, the same concept which we have discussed for alcohols. The smaller part will be with O is now alkoxy group and decides the prefix. If cyclic groups are present, then add the word cyclo before the name, yes. And you have to name the parent chain in a way so that your carbon is nearer towards the functional group and gets the lower number. Again the same concept, you have to always get your functional group with the lowest possible number. So if alcohol is present, if you have also alcohol in the given group, remember OH groups gets priority. If more than one ether group is present, then add di-tri to show the number, right? Just like you have diethoxy ether. So examples, you have the following examples. So CH3, OCH3. So what will be the common name? The common name will be simple, it is dimethyl ether. And here you have methyl group as well as the phenyl group. That means you know that you have to name in such a way that your alphabetical letter is given preference. So M comes first and then comes P, so it will be methyl phenyl ether. And here, yes, ethyl first, then phenyl, so it will be ethyl phenyl ether. Now let's look at the IUPAC names, right? These are the common names. But remember, the common names we have seen that will be different from IUPAC names. IUPAC names are the standard names. Okay, don't get confused in your questions also. IUPAC names have methoxy. For example, if you go back, if I have to give an IUPAC name, you have to select the longest carbon chain in the parent chain and it decides suffix. Then the smaller part with oxygen is now alkoxy. So if I name according to the IUPAC system, I'll get an alkoxy. It might be ethoxy, it might be methoxy. So obviously here you have a methoxymethane, because you will select one carbon here with the functional group, so that will become methoxy and the remaining thing is methane. The same thing here, you will select carbon and the functional group will be near to this instead of C6H5, because you have to select your functional group that has a minimum number while numbering, right, while naming. So here after methyl group itself you have this functional group, so it will be methoxybenzene. So here it will be what? Here it will be ethoxybenzene, because here there are 6 carbons before oxygen, here there are 2 carbons towards the right side of oxygen. So if I start from right only, my oxygen will be at the minimum number. So if it will be present at the minimum number, I have to select that sequence. So if I select that sequence, it will be ethoxybenzene. So these are the different concepts of nomenclature of your alcohols, phenols and ethers. So students, now I believe that if I give an alcohol, if I give a phenol or if I give an ether, you will definitely give an IUPAC name for it, right? Because till now we have discussed how to give a name for your alcohol, phenol and ether. So I hope you enjoyed this part, and from now onwards you will name an IUPAC name specially for a given alcohol, phenol and ether, right? So we'll meet in the next part, and in the next part I will be discussing about your different preparation techniques of your alcohols, phenols and ethers. So till then, stay tuned to our sessions. Take care. Goodbye.